Okay, so this is lesson 1, so hopefully you have the guided notes in front of you, and basically that's just what this video is. It's just me going through the guided notes with you. Alright, so this was Professor Prentice's guided notes for 1.1 in college algebra. Alright, so what we're going to go over today is we're going to recognize common sets of numbers, which a lot of this should be stuff you know. Alright, so especially the number stuff. Maybe getting to the applications might be a little trickier, but again, most of this is stuff that you've seen in Algebra 1. This is Algebra 1 material. Because college algebra is sort of a combination of Algebra 1 with Algebra 2. Alright, so if you took those in high school, hopefully most of this will be coming back to you as we kind of go over, and it's sort of just putting it all together in college algebra. Alright, so we're going to go over recognizing sets of numbers, applying order of operations, because that's very important, scientific notation, because your calculator will spit that out a lot, and some other things, applying problem-solving strategies, and looking at some application problems with percents and conversions. Alright, so the number groups that you should be familiar with. Now, everything that we're going to do in this class should fall in one or more of these number groups. Alright, so first of all, the natural numbers. These are the counting numbers. The numbers you use, I'm going to count to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, those are the numbers where they're no fractions and decimals. And they're all positive. Alright, so positive 1, positive 2, positive 3, positive 4. Alright, so those are when we say natural numbers. Alright, the whole numbers. Basically, they're the natural numbers where we've now included 0. Alright, that's the only difference. Alright, they're the natural numbers plus 0. Alright, so these are usually the set that we use when we're counting people. Right, when we say I'm going to count the number of students in this class, I'm going to count the number of movies I watched last week. I'm going to count the number of DVDs I own. Right? This would be the set that you'd use, right? Because you have to have a whole number person. But you could have 0. You could count nobody's in the room. Right? And then you'd count, it'd be 1, 2, 3, 4, 5, and so on. Alright, so the whole numbers are the natural numbers plus 0. Integers. Integer sets one of the big sets. A lot of times this will show up in our definition, so it's important that you know what it means. Alright, the integer set is now going to allow us the negative numbers. So it's the natural numbers. Right, 1, 2, 3, 4, 5. 0. Right, so it's the whole numbers. Then we get to add their inverses. And the inverses means the negatives. Right, we get to go on the opposite end of the number line, right? We get to go to the positive side of the number line and the negative, the inverses. And so now we just throw in the negative whole number values. Negative 1, negative 2, negative 3, negative 4, and so on. Still, integers, what's important about integers is there are no fractions and no decimals. They're the whole numbers that include 0, the positive whole numbers, and the negative whole numbers. And a lot of times we'll use integers. We'll say, give your answer as an integer. Or in the definition, it'll say integers in it. And you should know what that means. So if some definition's being defined for the integers only, you should know that means just the whole number values, including 0, both in the positive and the negative directions. Right, rational numbers is the big set. This is where we get to now include fractions and decimals. So basically these are, I'm adding to them each I go, right? I start with the natural numbers. I get to the whole number, I get to include 0. I get to the integers, I get to now include negative whole number values. Rational numbers are now where I get to include fractions and decimals. Alright, so the rational numbers can be expressed as a ratio of two integers. So there's, like I said, integers tend to show up in our definitions. There's the first definition, where integers, meaning I have a fraction where I've got a whole number value in the numerator and a whole number value in the denominator, where the denominator can't be 0, so that division number can't be 0. Every integer is a whole number value. Right? Every integer follows this because I can always divide by 1. Rational numbers can be expressed as decimals, and they have to be decimals that terminate or end, or they're repeating. Right, now, I'll give you examples of those to show you what I mean by decimals that terminate or repeat. Alright, so example, negative 2 is a whole number because I can write negative 2 as negative 2 over 1, so it satisfies the condition. It's a ratio of the integers negative 2 and 1. 2/3, alright, 2 divided by 3. Alright, that's a rational number. 0.2 is a rational number. 1/9, which is the decimal 0.11111 repeating. If you type that in the calculator, it gets 0.111111 goes forever. That's irrational. That's what we mean by a repeated sequence. Your 1/3 is the same way, right? 1/3 is that 0.3333 going on for forever. 0 is a whole number value, or 0 is a rational number. Negative 1,000 is a rational number. Negative 50.3 is a rational number. Square root of 4 is a rational number because I can rewrite it as 2, and 2 is the same as 2 over 1. Alright, and so basically the rational numbers include everything. They're all the whole number values, they're 0, and they're all the negative values, and then any fraction in between. Right, any fraction. Right, all of these non-terminating decimals can be written as fractions, right? Our 0.11111 can be written as the fraction. Same thing as something like 0.2, right? That would be our 2/5. You can rewrite that as 2/5. Or sorry, 1/5, not 2/5, sorry. That would be 0.4 would be 2/5, right? This would be the same as 1/5. Right? 0.4 is 2/5. And so on. So as long as it can be written as a fraction, where 0 is sort of a special case. Although 0 can't be, 0 over anything is 0, right? So it can be written as a fraction. So anything, as long as it can be written as a fraction, is a rational number. And so basically the rational numbers incorporate most of our values, right? Most of them. They're all fractions, all positive fractions, negative fractions, all decimals that can be converted to fractions, both the positive and the negative. They're the square roots as long as they're even square roots and they come out to whole number values. Those work. Alright, and so those are the rational numbers. Alright, next one, the irrational. So our irrational set are the numbers which are not rational. Alright, the irrational numbers. And basically what that means is they are non-terminating, non-repeating decimals. You cannot express them as a fraction. Right? There's no way to do it. The decimal goes on forever and it never repeats itself. Alright, and so rational numbers. So they have a decimal representation, they do not terminate, they do not repeat, they cannot be written as a fraction. Alright, so the easiest one, if you remember, is pi. Pi is an irrational number. It can be written as, again, it's non-terminating, so remember, it's our 3.1415, and then it keeps going on forever. And pi goes on forever. The e, the natural number e is an irrational number. That's our 2.7182, and again it goes on forever. It never terminates. Any root that's not even, so like the square root of 2 or the square root of 15, right? Those are non-terminating. If I write them out, they're ugly numbers. They're decimals that go on for forever. They never terminate. And I cannot write them as fractions. Alright, same thing for if I wanted to do the natural log of 5. Natural log of 5 is a number. Right? It's natural log, and we'll do logs later on in the semester. But I can type that number into the calculator. Natural is I can hit my ln key of 5, and it comes out to 1.609, and it's also, so again, the natural log of 5 is a number. It's just an irrational number, just like e is an irrational number, and pi is an irrational number, and the square root of 2 is an irrational number. So any number that's sort of what we consider an ugly number, that cannot be converted to a fraction, cannot be converted to a whole number value, cannot be, again, expressed as those. They're non-terminating decimals, and they don't repeat. They're not nice decimals like our 0.33333, or our 1/4 that's 0.25, right? Something like that, right? 1/4 would be rational because 0.25 is terminating. Right? These are not. These are ugly fractions. So those ugly fractions that don't repeat and don't terminate are irrational numbers, and irrational numbers are fine. Some of the solutions are irrational, and they're perfectly fine numbers. Right? Pi is actually and e, the natural number e, are actually very important irrational numbers. Alright, we will do everything in this class. When we get to applications and things like that, will be done on the real number values. The real number values basically incorporate every single number set I just talked about. Real numbers are all of the integers, all of the rational numbers, and all of the irrational. Basically, any number that I just talked about, any number that shows up on my number line, is a real number value. Alright, so real numbers include basically everything. All irrational, irrational number, all whole numbers, all integers, positive, negative, in every direction. Alright, so now I'm just going to give you some examples that I just want you to classify. They're all real numbers, but classify, and they may fall into more than one group, so again, kind of builds on itself, so oftentimes it will land in more than one group. Alright, so the following examples, I want you to classify them. They're all real, as a natural number, whole number, integer, rational, or irrational, and like I said, they could fall into more than one category. Alright, for example, 0. Alright, 0 falls into the whole numbers. It's a whole number. It's a rational number. It's an integer. It's not an irrational, though, so it's just those three. Whole number, integer, and rational. 50.36. Alright, 50.36 is irrational. Alright, and that's it. It's just irrational. E squared. E squared, well, it'd be the E term where I squared it, and if you type it on the calculator, you'll see that it's a non-terminating decimal. That's an irrational. Square root of 16. Alright, now that one's a little tricky. People want to assume square roots are irrational. But I can simplify. If you type in square root of 16, or if you just know this one, square root of 16 can be simplified to 4. 4 is a whole number. It's also a natural number. It's an integer. And it's a rational. Alright, so be careful with those. Square roots, we tend to want to say they're irrational, but that's not necessarily true. If I can simplify it, right, then it's all of those, right? And it's not an irrational number. Now, something like negative square root of 3, alright, negative square root of 3, there's no way to simplify that. That one is irrational. Alright, negative 50 over 2. Alright, negative 50 over 2, well, I can simplify to negative 25, and so that's, say, again, not all of those, because it's not the natural. So it's the integers, and it's a rational. Alright, integer and a rational. Alright, so again, hopefully you've done these before and can practice this. There's some on your homework, so you just have to, and it does ask you if there's more than one answer on your homework, make sure you list all of the cases it lands in. So if it's a whole number, integer, and rational, make sure you click on all three of those things. If it's just an irrational, it's just an irrational. And again, irrationals are kind of all by themselves. Or this one, it's just a rational number. Alright, next example is, which group of numbers would you say describes this number set? If I were to actually find numbers for these, which one would describe it? Would it be a natural number set that we'd be finding, an integer, rational, or irrational? Alright, so again, for the following sets of numbers, what are most appropriately describes the quantities? Again, and you can have more than one correct answer. I'm only going to give one, but you could get more than one. I'm going to get sort of the best one. Alright, so number of students attending ICC this summer. And so this would be a count, right? Technically, if nobody signed up, you could have 0, right? 0 students at ICC. Or 1 student to up to, you know, as many students, 20,000, 30,000, or however many is in there. And so this would be the count, which you could include 0 because you could technically have nobody in there. And so I think the best number group for this one would be our natural. Natural because it doesn't make sense to include negatives, right? So you wouldn't want any of the groups that include negatives. I wouldn't want integers because it doesn't make sense to have negative students, right? You have to have positive students. So that also throws out the rational. And then they're whole number values, right? Whole students. You can't have fractional students. So natural number is your best answer, right? If you're going to count how many students attending ICC, right, the type of number that you would use would be the natural number. Alright, the next one is like a survey, percent of people who drink coffee. Right, again, I wouldn't probably have negative numbers, but I could have fraction, right? I could have, 10.5% or 30.25% of the population drink coffee. And so since I can have these fractions, I then have to go past the natural numbers. And so I would say that this would be a rational. Now, even though we don't have negatives, we'd still have to include the fractions that are positive. And so the natural number is the best answer for that, right? Rational numbers would typically be what you would see. All right, temperature on a summer day in East Peoria. All right, temperature on a summer day. And so again, you know, we typically do whole number values, so 77, 83 degrees, 93 degrees. Now, if you were getting like you had a thermometer that went down to the 92.5 degree, it would depend on your tool. All right, so this one you could probably do integers if you wanted to, because again, if you're on an app, usually it gives you a whole number value. All right, so integers is probably what it is. But I would probably say, well, you could really do a fraction. It could be 92.5 degrees outside, right? If you have your thermometer out, 92.5 degrees. And so I would also probably choose rational for this one as well. Right, but integer would also be an acceptable answer, right? Either one of those would probably be fine. All right, number of movies you watch in a given year. Right, so if you're counting the number of movies you watch in a given year, I would say that would be our natural number again. Right, again, I'm going to assume you're counting only those movies that you watched all the way to the end, so you're not going to count fractions. So you watched 5 movies, 6 movies, because of quarantine, you could have watched 150 movies this year, right? Because we're stuck inside. And so I would say natural numbers is your best choice, right? Because I only want whole number values. I'm watching an entire movie. I don't know, it wouldn't make any sense to watch a negative, so positive natural numbers is what I would choose. Alright, we're going to stop the video there. So I'm break them down into short little videos so you don't have to watch them all in one sitting. Alright, so I'm going to stop the video here. I'll pick up the 1.1 notes in the next one. I sort of break them off in sections of topics. Alright, so we will stop there and pick up the video for the notes in the next lecture.